So we started off by using programs that you put values hard-coded in there, just these numbers you typed into your code, and then you executed your code and it used those values. Then we moved on to variables, where we looked at things by name, so we could change what those names were assigned, and then we would have our code do the right thing still, because we didn't have the same number copy and pasted throughout the code. Then we moved on to user input, and we used scanner. Now we're going to move on to how to make your program make decisions based on the inputs that you get, or based on the value of variables. If you're writing your own app, we go back to that like dialer example, and someone types in, 911, you might want to make the screen light up red. Make sure this is on purpose kind of thing. Otherwise, leave it alone, or just don't do anything. There's lots of reasons inside of your apps where you want to make a decision of if this message has already been read, show the scene button, or show like a red outline of a square instead of a filled in square. All these different things, you need to do different things based on the state that you're in. And we do that with something called an if statement. So first we're going to look at the idea of how this works. So this isn't real code. Don't try to copy this and use it as code. That's why I have everything in italics. The idea is you have an if, and then you have some condition. It's either going to be yes or no. And then you have the code or the steps that you take if that condition is true. So if it is raining, bring an umbrella. If it is raining, then bring an umbrella. If it's not raining, then you just don't do this. And you all make decisions like this every single day. No one goes through their day doing the exact same thing. On a daily basis, you have to look at the things that you have in whatever sense, whatever case you're in, what time is it, how much money do I have on me, whatever, and make decisions based on that. Let's have some examples. I want you to give me examples where you have if something, then something else. If this is true, then I do this thing. If I want to go outside, put on my shoes. If you are hungry, go eat. If you don't understand scanner, go to Ryan's office hours. If the total is more than $50, apply a 10% discount. If something happens, so if a condition holds, then we take some action based on that condition. When we write steps like this, we have certain things that are inside the if and things that are outside of the if. The things that are outside of the if, we do unconditionally. So we take it in the morning, you grab your TSU ID, you grab your keys, maybe grab your wallet. Then if it is raining, you take an umbrella, then you take a raincoat, then you lock the door, then you go to school. But if it is not raining, you skip this, but you still do everything up here and you still do everything down here. So the indentation here is to show you what is inside of the if, and that's why we indent things, or why all my indentation is the way it is, and why you should try to kind of match that in your code. It's a lot easier to read this when you have that than if it's just flat on the side. It's easier to understand what is under the condition, what is affected by the condition, and what is not. You have your, if I want to go outside, put on my shoes. What other things might you put around that? All right, so you're gonna, before it, say put on socks, and then if I want to go outside, put on shoes. Play music, that's good. Put in your headphones, listen to music. You're gonna do that regardless. Whether or not you go outside, you still want music to listen to. I like it. So these are the kind of things you want to think about. Always remember, like, what's inside of those braces is going to be affected by the condition, but what's outside of the braces will not. So let's look at actual code now. We have our cost of textbook, we have the money in our wallet, and we say if the cost of textbook is equal to 250, and we have the money in the wallet is equal to 100, so cost of textbook is 250, money in wallet is 100. If the money in my wallet is less than the cost of textbook, I'm just going to print out I can't afford it. This is the mathematical less than operator here. So if the thing on the left is less than the thing on the right, and the condition is true, and we enter the if statement. You can also reverse this mathematically and say if the money in my wallet is greater than or equal to the cost of the textbook, then I'm buying a textbook. So let's throw this in REPL and actually look at this running. So we have this set to 250, we have this guy set to 100, we run our code, it comes into this if, it says money in wallet, which is 100, less than 250, so it evaluates that expression, evaluates money in wallet is less than cost of textbook. That is true, so it enters the if and it prints I can't afford it. If we take what's on our next slide here, we can paste that. So I say if money in wallet is greater than or equal to the cost of a textbook, I'm buying a textbook, but that is not the case here. Since we don't have like the greater than equal thing on our keyboard, like greater than with a line under it for greater than or equals, this is how we express that. Same thing with less than or equals, it's a less than equal sign. If I change the money in wallet to be 300 from 100, now this is true. Money in wallet is greater than the cost of the textbook. So I'm buying a textbook. I know the greater than or equal to thing is weird, but it is much better than having to go look for the symbol for greater than or equal like this one. So we can type that. The order here matters too. If you wrote equals greater than, that won't work, or equals less than. So here's another example. We have our bank account balance and we have the amount we want to withdraw. We say if amount to withdraw is greater than bank account balance, insufficient funds. So if my bank account balance is 10 and I try to withdraw 20, I'm going to print insufficient funds. All these expressions are going to get evaluated where the variables will be replaced with the values that they hold at that time. I can open this one up in REPL directly because I was smart enough to put a link in. So here's an example where I set my bank account balance to 400. Print how much would you like to withdraw here. Then I read in an amount to withdraw from the keyboard, and then it will compare that, and it will print insufficient funds if I'm not allowed to. And then down here there will be other code, but let me give this a run here. So how much would you like to withdraw is here on line 7. Now our code is running on line 8, and it is waiting for us to type something. So I say I want to withdraw $10, and it's fine. Everything works. I run it again. I type I want to withdraw $700, and I hit enter, and it prints insufficient funds. The number 700 was right here, came from this keyword.nextInt, went into the the int amount to withdraw. Then on the next line, it compared that number 700, the bank account balance. It was greater than the bank account balance, so it printed insufficient funds. These are all of our comparators. We can use these to compare our integers and our doubles. You can say one is less than the other, one is greater than the other, less than or equal to, greater than or equal to, not equal to. So the last two are especially worth talking about. Equals is for comparison. So we know that one equal sign is assignment. You know that one equal sign means take what's on the right and store it in the variable on the left. If you want to do comparison, you use two equal signs. If you use one equal sign, you will not get what you want. So equals is the comparator. That will tell you whether two things are the same value. Exclamation point equals means not equal to, instead of like an equal sign with a slash through it. Since this is like the mathematic one, not equal to, again, we don't have a key for that, so we use not equal to. The order here matters, just like the order here matters. If you write equals and then the exclamation point, that's a different thing. If you write equals less than or equals greater than, instead of less than equal, greater than equal, and not equal, you are typing something different. These are comparison operators. Here's an example with the equals. I have my balance, I have my amount to withdraw, and if they are the same, if amount to withdraw equals bank account balance, I print out you have exactly enough, only if they are exactly the same. So let's go get a quick exercise here. Something that I need to actually make very clear that I should have made clear earlier is, what do we notice about this line that is different than the other lines? It doesn't end with a semicolon. Exactly. If you put a semicolon right here after this parenthesis and before this brace, your code will run this regardless of whether this condition is true or not. So don't put a semicolon on this line. If your line ends with a brace, don't put a semicolon on it. So it's open brace, and then the next line you indent again, and you go in, and then you have your close brace, and then after that it will be flat here. So the indentation indicates what is controlled by the if. If you do things on just one flat column, no one will be able to understand what your code does. Let's take a look at this assignment together. Write an if statement that prints the word run, exclamation point, if there are less than 15 minutes until class starts. So what's the first thing I need to write? If. Now what's my condition? What am I checking? I'm comparing two things. What are the two things I'm comparing? Minutes until class starts, and all right, so I'm going to say minutes until class starts, and then what am I comparing that against? 15. If I want to know if the minutes left is less than 15, so I use my less than operator. The thing on the left is less than the thing on the right. I don't put a semicolon on this line. Instead I put an opening brace, and every open brace needs a close brace. So that just gave me that. REPL just added that close brace for me. I didn't have to type it. And then inside of here, system.out.println run. Now if I change minutes until class starts to 30 from 11, when I hit that if, it's going to say, is 30 less than 15? No, it's not going to go into the if. It's not going to run the code inside of those braces. So now you have a program that can act differently depending on the state of things, depending on how much time is left. We don't always do the same thing every time. What I want to talk about now is what's really going on inside those parentheses, where I have A is less than B, where I have cost of textbook is greater than the money in the wallet, or whatever. That expression itself has a type. Anyone want to guess what that type is called? It's boolean. It's called a boolean, or bool for short. We can name it. It is a type we can have here. So instead of saying, as I had earlier, I had if bank account balance equals to amount to withdraw, and print out you have exactly enough. Here, I'm creating that Boolean outside, and then I'm checking this guy here. So Boolean exactly enough is going to be the result of bank account balance equals amount to withdraw. Bank account balance equals 3 here, amount to withdraw equals 3. I said Boolean exactly enough equal to the result of that comparison, and I run it, and I get you have exactly enough printed out. If I change the bank account balance 4, now they aren't equal, and I don't print anything because we won't go inside that if now. So they're just taking that body, that comparison, pulling it out and putting it into a separate variable. Here we have the example of actually printing the Boolean. So if I say bank account balance equals 3, amount to withdraw equals 3, Boolean exactly enough equals whether those two are the same. We have system.out.println exactly enough. What is this going to print? 3, true, 1, let's find out. It prints true. So if bank account balance equals amount to withdraw, that whole thing evaluates to true. It's not 3, it's not the value of those two, it's whether they're equal. So those of you that said 3, what if I change this to 5 and then said bank account balance equals amount to withdraw? It's false. So if you said 3, think about whatever makes you think this should print 3. What would it print here? Would it be 3? Would it be 5? So it doesn't make as much sense to think about it that way, or it doesn't translate well. Like when it's equals, I see how you might think, oh, it's 3 because it's going to be the result of comparing them and they're the same. But yeah, so these are the two values that a Boolean can hold: true and false. That's it. There's no maybes. Everything in computers is binary. It's yes or no, true or false. The Boolean type in action. Here's an example. We can assign directly these values true and false. Lowercase t true, lowercase f false. An example of a true one, an example of a false one. You usually won't pull the comparison out and do it on its own line. You're generally going to write the comparison inside of the if, like right inside that condition, unless you wanted to save the comparison for later, which is rare, but it happens. What I really just want you to understand is that on this line where I say amount to withdraw equals bank account balance, that is an expression that does get run. The language does have to turn this into something. It turns it into either true or false, depending on whether those two are equal. If they are equal, it'll evaluate to true. If they are not equal, it'll evaluate to false. And then if works by looking at it. If it sees true here, it goes to this line. If it sees false, it jumps to wherever it ends. So it would jump down here and then continue. Now let's look at the AND operator. The AND operator takes two Boolean expressions, and it is true if both of them are true. If I want to go outside and I'm not already wearing shoes, put on shoes. If I am hungry and I have food, eat that food. This will only be true if both things are true. So if I don't want to go outside and I'm already wearing shoes, I don't put on shoes. Or if I do want to go outside and I already have shoes on, then I don't enter this. So let me change this here. So if I said, if I want to go outside and not already wearing shoes, then put on my shoes. So if either of these things is false, we don't do this. If I'm wearing shoes, I don't put on shoes. If I don't want to go outside, I don't put on shoes. Only if both of those things are true. So here's an example of that. Do we have time to eat before class starts? So we have the money in our wallet is $5.50. We have 45 minutes until class starts. Now we have two Boolean things here. We have, do I have enough money, which is going to be whether the money in wallet is greater than 5, and do I have enough time, which is if the minutes until class is greater than 30. So we need both of these to be true if we're going to go eat. If I only have 5 minutes till class starts, it doesn't matter how much money I have. I don't have enough time to eat. If I have 4 hours until class starts, it doesn't matter how much money I have. I don't have enough money to buy food. Here's that same code. If I run this, I have time to eat. If I change money in wallet to $4.50, what is the value of enough money going to be? False. Right. Now what's the value of enough time going to be? So what's the value of this whole expression? Two things have to be true for the whole thing to be true with an AND. So if I run this now, I'll get nothing. If I change money in wallet back to $5.50, but I change minutes until class to 5, then the whole thing is still false. And if I only have $1.50 and I have 5 minutes to class, then obviously I don't have time to eat. So still false. So if either one of them is false, the whole thing is false. And that is how AND works. Usually we won't pull these things out onto their own lines and put them into Booleans. We'll just say if money in wallet is greater than 5 and minutes until class is greater than 30. So now we have this line of code that just does a comparison for us. These have higher precedence than the AND, so it's not going to do like 5 and first. 5 and minutes until class starts first. It parenthesizes it like this way. Does this one, then it comes over here, minutes until class starts is greater than 30, so it gets a true and false, and then it adds those two together. So this is the, we call this a truth table. You have the operator here, and you have the values here. So true and true is true. True and false is false. False and false is false. False and true is false. If this notation doesn't make sense to you, you can also just look at it like this and say true and true, the result is true. False and anything is going to be false for the whole thing. We have another operator called OR. So and we do with 2 ampersands. 2 ampersands, not 1. If you write 1, you'll be like, hey, this kind of works, but trust me, it doesn't. We have the OR operator, which is 2 pipes. That is the key right above the backslash, like shift on the backslash key, right under backspace. We call these pipes because they look like pipes. So here's an example of that. If it is the weekend or I'm feeling sick, stay home, because we are lazy on the weekends. And if I'm feeling sick, I'm not going to class. If either of those things is true, then the whole thing is true. So if the total is more than $50, apply 10% discount. We could say if the total is more than $50 or they have a coupon, apply a 10% discount. They don't need to be buying more than 50 and have a coupon. They just need one of those things. So if you just need one of your 2 conditions to be true, then you use OR to combine them, stick them together. We can look at this as a table as well. False or false is false. So if both of them are false, the whole thing is false. So you only need one of them to be true. You can look at the results again the same way. True or anything is true. False and anything is false. We have 2 variables we need, feeling hungry and hour of day. Boolean, feeling hungry. Let's say true, because I'm hungry a lot of the time. And then we're going to create an int, hour of day, and let's say it is noon, so 12. We know we're going to have an if with some condition in it, and then inside of that if, we're going to print system.out.println. The question is what goes inside of these parentheses. So we need both of these things to be true. So that means we're using what operator? And then. This is going to take 2 things. So what's the first thing we want to know? We're feeling hungry, right? And then we have to check that it is not too late to go out. So we're going to check hour of day, and then what's our comparator? The less than, and then 21. And we run this, I'm going out to eat. And if I change hour of day to 23, it shouldn't print anything because it's too late to go out. If I change it to 20 again, and I just say that I'm not feeling hungry, that also shouldn't print anything. So I'm not feeling hungry, even though it's early enough, we still don't go out. For that last piece, I want to make sure that it is after 7, so I just need to have one more condition that holds. So I put another and on the end of this, and I say hour of day is greater than 7. or greater than or equal to 7. So 20 still meets that. If I change I'm feeling hungry to true when I run this, that should be good. If I change the hour of day, I'm not going out, nothing's going to be open. Let us move on to the last thing we're going to talk about today, which is else. An else is for when you want to not just do something under a condition, but you have two paths that you're going to follow. You have the yes case, you have the no case. If something is true, do this. If it's false, do something else. Again, this isn't real code because I have spaces in the middle, but an else case is going to be a brace, the word else, and then an open brace. It'll be on the same line as a closed brace for the if, and then you have what you do otherwise. So if we're going to go out, we're going to take some kind of coat with us. If it is raining, I'm going to take my raincoat. Else, or otherwise, I'm going to take my regular coat. Still no semicolon on the line with the else, still no semicolon on the line with the if up there. So if the condition is true, we do what's here, and if it's false, we do what's down here. So let's look at the real example of this. I think I had both of these strings earlier, but now we can see how we can print both things in one block of code. So if cost of textbook is $250, money in wallet is $300. If the money in my wallet is less than the cost of a textbook, I will say I can't afford it. Else, I will say I'm buying a textbook. Keep in mind what these braces do. The braces mean like this is what is managed by this if, and these braces mean this is what is managed by this else. So if this is true, we come in here, and then the else, it just jumps right past that instead of running the code inside of it. If this is false, it jumps past this to the else, runs the code inside of that. So let's open this up in REPL. So I have cost of textbook equals $250, and then money in wallet equals $300. What is this going to print if I run it? Cost of textbook equals $250, money in wallet is $300. So is money in wallet less than the cost of the textbook? Okay, so what are we going to run? I know this whole condition is false, so that means we skip everything inside of here, right? See that this condition is false, money in my wallet is less than cost of textbook, and it's going to jump down to the else case and then run whatever's inside of that. There's no rechecking of conditions here. It just jumps, skips whatever's in the if, goes down to the else case. Every time you have an open brace, you need to close it. So this is like contained by the main method, and this is contained by the class main at the bottom. Here's an example of like a toy program. Creates like some secret number, and in like a real version of this program or a number guessing game, you might randomly generate the number, but we have our secret number in the code, so the user can't see this. We say like, you know, I'm thinking of a number between 1 and 10. What is it? We read a guess from the user, so they type in 3, let's say, and we check, is the user's guess equal to my secret number? Is this going to be true or false? If the user types in 3, false. So we're going to have 3, is 3 equal to 5? We get false, so we skip this line, and we jump down to the else case, and then we print out, no, it's not 3. If they answer 5, and this compares true, we run what's in here, we print you got it, and then we skip the whole else. So if the condition is true, whatever condition is up here is true, we run what's in the if. If it's false, we run what's in the else. So what I would like you guys to do, is go into exercise 4.2 and add an else case saying, I'm not going out if that condition doesn't hold, if you're not hungry or if it's not the right time of day.